Good day guys, welcome back to the King Junior class. In our last class we looked at Introduction to Logarithm, which our brother me to. And I believe you also enjoyed the class. Okay, so for this class we're looking at Indicals, but before we look at Indicals in Logarithm, we'll be looking at the assignment he gave you last. Okay, so we have number 1 to be log 8 minus log 4 minus plus log 32. In which case to solve these, as they are explained, you are going to be using the laws of logarithm to solve. So the basic thing about logarithm is to know the laws of logarithm. There are good to go. So in this case, I have number 1 to be log 8 minus log 4 plus what? Log 32. In which case, everything is in base 10. Why? Because any logarithm without a base is in base 10 generally. So in this case, I am going to be having what? Log what? 2 raised to power 3 minus log 2 raised to power 2 plus log 2 raised to power 5. Now, the basics for my expression this way is to make sure that what each of these values has the same base, with their different respective powers. So I can easily merge them together. Now, since they have the same base, and they have the same, this base, they log base 10, and they also have the same base for each respective powers, I can now join them together using the laws of logarithm. For minus, I'm going to what? Dividing, which becomes log 2 raised to power 3 over what? 2 raised to power 2. Then I can split this out like this, that's what log what? 2 raised to power 5. In which case, using indices, I'm going to have that what? Log 2 raised to power 3 minus 2. That's what? Then plus what? Log 2 raised to power 5. In which case I have what? Log 2, that's raised to power 1, plus log 2 raised to power 5. Now, merging these two of them together with respect to the laws of logarithm, that becomes what? Log base 10, 2 raised to power 1 times what? 2 raised to power 5. Okay, so in which case, that now becomes what? 32 times, that's log what? 64 base 10. So, that is for that. Then for number 2, we have what? Log x base 4, which is equals to what? Minus 2, 1 over 2. Now, in this case, what will I do? Now, the first thing I have to do is what? Make this an improper fraction to make the equation basically easier. So that becomes what? Log x base 4 equals to what? Minus 5 over what? 2. When I convert to improper fraction. Now, in which case, let's take 4 to this side with our law of logarithm. Which becomes what? X equals what? 4 raised to power what? Minus 5 over what? Over 2. Now, 4 can be expressed also as what? 2 raised to power 2. That becomes x is equals to what? 2 raised to power 2. All raised to power what? Minus 5 over 2. Now, if you remember our law of indices, whenever I have a raised to power m, all raised to power 1 over n, or all raised to power n, the same thing as saying what? A raised to power what? M times what? 1 over n, or m raised to power, or m times n in that case. So, for this, I'm going to have that what? 2, all raised to power what? 2 times what? Minus 5 over 2. Where 2 cancels out with our over 1. And we have what? 2 raised to power minus 5. Finally, x becomes what? 2, 1 over 2 raised to power 5. Where we said what? Minus represents what? 1 over, then we have 2 raised to power 5. 1 over what? 32. So, let's now move on to indicals. For indicals now, seeing these equations, we have 3 raised to power x equals 27, 2 raised to power x equals 3, 2 raised to power x plus 1 equals this, and number 4. Now, this case, the way we solving it is going to be actually different. Why? Because for our normal way of solving logarithm, or solving indices as it were, it's such that if I have, if you say 2 raised to power x, I'm going to have something like 32, or 16, or 4, or 8, such that I can raise any of these as 2 raised to power something to get them. But in this case, I cannot, if you observe well, I have 3 raised to power, okay, for this I have 3 raised to power x, which is equal to 3 raised to power 3, I can get that. But for this, it is basically different, which in this case, I might have to apply logarithm to the equations. Now for this, we have number 1, solution. 3 raised to power x is what? Equals to 27, implies that what? 3 raised to power x is equals to what? 3 raised to power what? 3, where 3 raised to power 3 there is what? 27. And from this case, since they have the same base, you can forsake them and have x is equals to what? Equals 3. Now for number 2, we have what? 2 raised to power x is equals to 3. In this case, 2 raised to power something cannot give me 3. Or 3 3 raised power something cannot give me 2 raised power x or give me 2 back. So in this case, all I will just do is what? Introduce my logarithm, which becomes what? Log 2 raised power x equals what? Log what? 3 raised power what? X. 3 raised log 3. Now, as to our law of indices, I can bring x backwards, which becomes what? X log 2 equals what? Log what? 3. In this case, I'm looking for x. So my x becomes what? Log what? 3 over what? Log 2. Where you have to find what log 3 is, you know, I also have to find what log 2 is. Then you so that's how to get my x. Now for number 3. For number 3, sheet 5771. For number 3, we have 2 raised power x plus 1 equals what? 3 raised power 2x minus 5. In which case, as I solve number 2, I'm going to solve number 3 like that, introduce my logarithm, which becomes what? Log what? 2 raised power x plus 1 equals to log what? Log 3 raised power 2. 3 raised power what? 2x minus 5. Now, bringing our x plus 1 to the back becomes what? X plus 1 log what? 2 equals what? 2x minus 5 log 3. Now, as I explained earlier, I have to find my log 3 in my calculator, which I'm also going to be doing here. That becomes what? X plus 1 times what? 0.3010. Then 2x minus 5 times what? 0.5771. Now, in which case, I will expand. While expanding, I have what? 0.3010x plus what? 0.3010. This times x is this times 1 gives us back. Then you have to multiply this also. That becomes what? 0.5771 times 2x minus what? 0.5771 times what? 5. On top, I'm going to have this is what? 0.3010x minus 0.5771 times 2x equals, take this to that side, becomes what? 0. Minus 0.5771 times 5 minus 0.3010. Okay, now from this point I add what? 0.3010x multiplying this. I add all this by multiplying with this. How I got it, I just collected like terms by saying what? Leave this here, bring this to this side, becomes minus. Leave minus this here, bring this here to become what? Minus. On solving, I'm going to have the solution of this to what? 2.6865 or what? 0.6532. Now note, for log 3, it is 4771 as I wrote before. So kindly correct that. 4771, this, and so on. So the answer is what? 4.11. 4.11. And that is going to be all for this video. Thanks for watching our video for today. And in our last class, in our next class, we're looking at graphical representation of logarithm. So most likely, team talk, which is for teaming, will be coming up for that video. Thank you.